Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Honors Geometry class. We are continuing with our knowledge of circles, and today we're going to actually learn a little bit more about these angle arc theorems, okay? We've learned a lot of these theorems already. We've learned about central angle theorem, the inscribed angle, tangent-tangent, secant-secant, tangent-chord, secant-tangent, chord-chord, inscribed angles, exterior angles, and today we're going to continue with that. And we're going to learn some theorems today, and these don't really have names, so this is a Mr. Morrow name. I want to make that clear. But again, in a lot of geometry books, it's very difficult because, for example, this one should be like Theorem 84. How do you remember theorems by numbers, in my opinion? So I try to look at the theorem itself and then put an actual name to it that relates to the definition. So this one is called the inscribed or tangent chord pairs theorem number 1. And it states, gentlemen, that if two inscribed or two tangent chord angles intercept the same arc, then they are congruent. So if two inscribed or two tangent chord angles intercept the same arc, then the angles are congruent. So in the figures below, gentlemen, I've given you one figure to the left with two inscribed angles, and the figure on the right, I've given you two tangent chord angles. How does this theorem work? Well, let's first look at this guy over here. Okay? Look at angle X and look at angle Y. Do not, I don't know if that was proper English, doesn't or don't angle X and Y intercept arc AB here? Do you see that, guys? So since angle X intercepts arc AB and angle Y intercepts arc AB, then angle X and angle Y are congruent. So since angles X and Y intercept the same arc AB, that will automatically make angle X congruent to angle Y. Think about it though logically, guys. Let's just go ahead and say that arc AB was 40, just for giggles. What would angle X be since it's an inscribed angle of that arc? 20. What would angle Y be since it's an inscribed angle of that arc? 20. That's why. Okay? So when two inscribed angles intercept the same arc, they are congruent. Now it's identical to the tangent chord because if you remember, tangent chord is the same formula as an inscribed angle. In this particular case here, if this angle A here and this angle B, doesn't this angle intercept this arc right here? From this point, okay, to this point. Doesn't that intercept that whole arc AB? Yes, sir, my brother.
Doesn't that form a right angle?
It absolutely doesn't. No, it's not on the. It does not form a right angle because it's not going through the center.
The tangent doesn't form a right angle.
The tangent forms a right angle when it intersects with the radius. But AB here, this guy right here, is not a diameter. It's not going through the center. Thank you for caring and asking. Good job. Then angle B here. Does an angle B also intercept this same arc AB? So therefore, angle A will be congruent to angle B. Why? Same exact reasoning. Since angle A intercepts arc AB and angle B intercepts arc AB, angle A will be congruent to angle B, period. Come again, my brother? I'm sorry? Okay, there are two angle A's. Good point. But I'll prove that I'm right either way. Doesn't this angle intercept this arc right here? And doesn't this angle intercept this arc right here as well, sir? So whichever A you're looking at and whichever B you're looking at, the angles that intercept the same arc will be congruent. Yes, sir, my brother. Yes, sir. I love it. This is what I love. This is what I love about this class. You guys think. Angle A will be congruent to angle B because both angle A and angle B intercept arc XY. Very astute of you. Well done. Not bad, right? Pretty simple, right? Okay. Next. This is called the Inscribed or Tangent-Chord Pairs Theorem 2. And this states if two inscribed or tangent chord angles intercept congruent arcs, then they are congruent angles. So if two inscribed or tangent chord angles intercept congruent arcs, then the angles are congruent. So what's going on here? If you look at angle P here, gentlemen, APB to be exact, it intersects arc, or intercepts with a P, arc AB. If you look at angle CDE, this angle intercepts arc CD. If arc AB is congruent to arc CD, then angle APB is congruent to angle CDE. If arc AB is congruent to CD, then angle APB is congruent to angle CDE. So it's the same as the top one, except it doesn't necessarily have to be two inscribed angles on the same arc. If you have two inscribed angles or two tangent chord angles that intersect the same arc, those angles are congruent. But like in this circle here, if I have one inscribed angle and one tangent chord angle that intercepts congruent arcs, those angles are congruent as well. Sir, and then sir.
So on the proof, if you had a like that, they have to specifically state AB's congruent to C.
Correct. Well, one or the other. I could do the converse. If on a proof, my brothers, I told you that this angle was congruent to this angle, then you could immediately say, because of the converse of this theorem, that arc AB would be congruent to arc CD. Vice versa. Yes. They got to give you one or the other, though, is what I'm saying. Very good man. Sir, my brother, thank you.
I have a question that goes back to the first.
Yes, sir.
For those triangles there, that means every angle in that triangle is each other.
No.
Each other.
Okay, very good. These two triangles here, all of the corresponding angles will be congruent. Yeah, because these two are vertical, these two are congruent, and these two are congruent. Yes, sir.
But you base that off the fact that they intercept the same.
Because they intercept the same arcs. Yes. And then these two will be congruent because they're vertical. Yes, sir. Yes, those would make those similar triangles. Yes, sir, they would. Did I say congruent? No. No. Did I say congruent triangles? No. Congruent angles. Corresponding angles will be congruent. But the triangles are technically similar. Okay? Thank you, son. Good question. May I continue? Thank you. Okay, semicircle inscribed angle theorem. I like this one a lot. An angle inscribed in a semicircle is a right angle. Easy peasy. Check this out. Angle ABC here, okay? This is an inscribed angle. This is the diameter. So due to the central angle theorem, if BA is a diameter, isn't arc BA 180 degrees? Isn't an inscribed angle half of the arc that it intercepts? Doesn't this angle here intercept arc AB? So therefore this has to be 90. But straight up, now as long as you see there's an inscribed angle in a semicircle, I guarantee you that angle is 90 degrees. If AB is a diameter of circle O, then angle ACB equals a right angle. That's a very powerful theorem. Basic. Most people could understand that because it's an inscribed angle, but instead of having to do double work and identifying the central angle and then taking half of it, you can immediately say, wait a second, if I have an inscribed angle inside of a semicircle, that inscribed angle has to be 90, period, no matter what, no matter how it looks either. Even if I went like this, guys, if I went like this, that sure may not look like a 90, but I guarantee you that's a 90 as well. I promise you. Okay? And last but not least, I see some people writing. I'll wait a second. Got it? All right. Last but not least, gentlemen, tangent minor arc theorem. Again, all of these are made up names, guys. So for those of you out there in the internet world watching this online saying, but my book doesn't call it that, I know it doesn't. I made these up. But I'm trying to make it so that you can remember the theorem. The tangent minor arc theorem states this. The sum of the measures of a tangent angle and its minor arc must equal 180. Now, we know what tangent means. We already know that PT is tangent and PS is tangent. We know from a theorem before that PT will be congruent to PS. Because when you have two tangents to the same circle originating from the same vertex, those two tangents are congruent. What we're learning now is we know that TS is a minor arc. How do you know it's a minor arc, Mr. Morrow? Because a minor arc is less than 180. Okay? Now we know that arc TS plus angle P will equal 180. I promise. So for example, let's say I tell you find angle TPS, but arc TS is, let's just say for giggles, 100 degrees. Angle P would be 80 degrees. Super powerful. Super powerful. Okay? Super powerful. So the sum of the measures of a tangent angle and its minor arc will always be 180. Pretty simple, right? Yes, sir, my brother. The tangents, these tangents are congruent. Not because of this law, but it's because whenever you have two tangents to the same circle originating from the same vertex, those will be congruent. We learned that earlier in the chapter. Okay? Thank you for verifying, sir. May I continue, gentlemen? All right. So example 1. You've got AB and AC are tangents at B and C. Find angle A. 60 degrees, done. This is the arc. But we know that this arc plus this angle must equal 180. So angle A will equal 60 degrees. It's literally that simple. Like I promise you. Some books don't even teach this, guys. I don't know why. But it's extremely powerful. Extremely powerful. Okay? Now for our second example, we're going to do a little blast from the past. You got it already? Good, good. If in circle A, okay, DF is a diameter, and the radius of the circle is 6.5 millimeters, chord FE has a length of 5, I want you to find ED. First of all, what can we immediately prove right off the bat? FED is a right angle because it is an inscribed angle of a semicircle. Beautiful, guys. If a radius is 6.5, then what is the whole entire diameter? 13. If FE is 5, so there's a 5, 12, 13 triangle. Pythagorean triples, once again, save the day. If you forgot your Pythagorean triples, remember the Pythagorean theorem. 13 squared equals EF squared, A squared, plus B squared, which we'll call DE in this case. And then that's 169 plus 25 plus DE squared. Subtract the 25, subtract the 25, 144 equals DE squared, square root both sides, DE equals 12. But darn it, it's a lot easier to learn your 5, 12, 13. But sometimes they won't be perfect Pythagorean triples. That's why I went ahead and did the math, just in case. Okay? Now, I know that we've been slowing down on proofs, and we're going to continue. This will probably be the last chapter you even see a proof on. That's it. We're getting to the end. Most books finish proofs a long time ago, guys. I want you to be proud of yourselves here. All right? We've done a lot of crazy proofs. So we got one more proof for today. Just one. And it involves a lot of old stuff as well. The only given they have here, my brothers, is that you have a circle O. They want you to prove two distinct things here. They want you to prove that triangle LVE is similar to triangle NSE. Crazy stuff. Okay, number one, the given. Huge given. I'm being sarcastic. Circle O. Ooh. It didn't give us much there, all right? However, what can you tell right off the bat? Yes, sir, my brother. Very good. And what other angles are congruent? I'm very proud of you, son. Angle V is congruent to angle S, and angle L is congruent to angle N. Why? Because if two angles intercept the same arc, then they are congruent. You could have used the inscribed angle pair theorem number 1, right? That's what we had called it. Inscribed or tangent-chord pair theorem number 1. Yeah, inscribed angle pair theorem. That's fine because you're activating the inscribed angles here, sir. And why again? V and S intercept this arc right here, my brothers, and L and N inscribe this arc right here, my brothers. Yes, sir. You guys are doing great. I love it. Thank you. Well done, my brother. Now we're going to prove one part of the proof. Triangle LVE is similar to triangle NSE because of angle. Very well done, sir. Very well done. Now, we're getting to the part that always jammed us up a little bit, guys. If these guys are congruent, come on, Moro, similar, isn't EV, the ratio of EV to ES equal to EL to EN? Because ratios of corresponding sides are similar, in similar triangles are congruent. Ratios. And then from there, we're going to go to means extremes, yes. But remember, before means extremes, we had this discussion before, you have to set up the ratio. EV, which is this guy right here, to ES is congruent to EL to EN. Could you have done EV to EL is congruent to ES to EN if you had so chosen? Could you have done that as well? Yeah. You could have said this to this is congruent to that. Absolutely. And either one of the proportions I have, either the one that I just wrote right now or the one that I already wrote in the proof, when you cross multiply those, brothers, you're going to get the last part of your proof, which is that EV times EN equals EL times SE because of the means extremes products theorem. And bada bing, bada boom, that's it. All right, guys. Hope you learned a lot. Thank you very much and have a wonderful day. Look.